Introducing All-Seeing SignalGPT, your AI copilot that transforms natural language prompts into executable software-defined radio programs.
My name is Tayo Shonibare, and today I would just like to do a very quick demonstration of a new software which we are developing at All-Seeing Technologies, which we call SignalGPT. So if you go to our website at allseeingtech.ca, you would see the SignalGPT there, and if you click on it, it should take you directly to the link. Otherwise, you can also go to signalgpt.ca on your web browser. So, SignalGPT is an AI copilot that helps you perform RF signal processing or spectrum management using an LLM interface. So instead of you programming things in Python, in C++, or using GNU Radio, you basically tell SignalGPT using the natural language what RF task you want, and it helps you do it. It helps you plan the spectrum management or even just RF signal processing. And it also has a feedback loop that it can analyze what results it has and what results you need, your intent, and it can improve it through the LLM loop. So this is just a very early demo we have. Let me show you what we have. The first step you want to start with is to log in. So if you go to our website, you can just use your Google account. And I am going to just log in with this account right here. And you are taken into our user interface here. So it feels sort of familiar. It's like your standard ChatGPT style interface. You have the chat box here, you have some login and logout information here, and then you have the chat UI. You also have a data visualization, and you also have an instructions tab right here. So the instruction tab tells you exactly how to use SignalGPT. The available blocks actually tells you what available software-defined radio RF signal processing blocks we have currently integrated. So currently we have almost over 500 blocks integrated into our system. So you can create other blocks, you can create complex to imaginary blocks, complex to I-short blocks, you can do IQ correlations, you can do all these things. But when you are integrating the blocks, you basically do it in a natural language format. So you tell SignalGPT, hey SignalGPT, I want to classify a signal, and SignalGPT has access to this curated block library we have here, and it basically performs that action for you. We can do a constant source, we can do AM demodulation, we can tell it to detect a peak, and all these were once GNU radio blocks that we've taken and trained our AI system to use these blocks in order to generate RF signal processing chains or spectrum management plans. So you can tell SignalGPT, hey, I want to classify this signal and generate a waterfall plot, but I want to only detect peaks above X parameters. You can give it that. You can give it information on like the regulatory information, geolocation, so on and so forth. You can give it. It's an LLM. It's very open world. You can tell it whatever you want to do, and SignalGPT basically answers you. So you see here we have so much. We've integrated so much blocks, and you can tell it, ask SignalGPT to create any signal. You can ask SignalGPT to analyze any signal. And the good thing is you don't need to do these in a very deterministic manner. You just interact with it like ChatGPT. Exactly how ChatGPT and other LLMs have revolutionized the software development industry. What SignalGPT seeks to do is a similar concept. We seek to revolutionize the RF signal processing industry with this LLM. So let's do a very quick demo. Let's go to the chat UI. And let's, introduce ourselves. Greet SignalGPT. You click hello and you do this, and you can see it's processing. And it's like, hello, how can I assist you with your signal processing project today? Ready to explore some advanced techniques. So let's just go straight to the point and tell SignalGPT, create me a diagram. So the first step you want to do is you want to visualize your diagram. Your software RF signal processing diagram. It helps in the whole process of knowing what's going on. So let's go create me a diagram with two sine wave source at 1 kilohertz and another one at 5 kilohertz and a noise source, all going to let's just have it going to a frequency sync. And let's click enter. And you can see it's processing. And you can see it's going through the whole process, and it's using the LLM loop. So this is not something that's deterministic. It takes in your intent, your natural language, feeds it through an LLM loop. We've trained that same LLM on the different available blocks you can see there. It then takes that your intent, your request, and it creates this block diagram that you can see here. And you can see I asked it to create two sine waves, 1 kilohertz, 5 kilohertz, to a frequency sync and a noise source. So that's one sine wave, another sine wave, a noise source it's adding it up. So I didn't tell it to, add this block. It just does that because it obviously, it has the LLM reasoning there, and it all goes to a frequency sync. And you can see it's all complex IQ streams. So if we then click run it, yes, let's go ahead and run it. You can see now it's mapping each block parameter precisely to ensure. So it's going through its LLM processing chain. So all this, it's not deterministic. It's all through the AI system. It can help you, visualize the spectrum, transfer these signals. You can then transfer it to a real-time software-defined radio, to a real-life software-defined radio, and so on. So let's just let it go. We've told it to run the flow graph. So let's see what happens. So you can see here, it then goes to observing signal in real time. So if we click on the data visualization tab, we should be able to see the signal. And there it is. So you can see there, it has this at 1 kilohertz and also at 5 kilohertz. So what SignalGPT basically helps you to do is, using this natural language format, we've been able to essentially create, a RF signal processing chain. We use this using GNU radio blocks. So, and if you're familiar with GNU radio, we can push this to real-time software-defined radios. We can create so many RF signal chains. Here, I just did a very basic demonstration for you. So let's close this of just creating this very basic system. But if we go to the available blocks that we have, so let's see, we can create blocks. We can tell it to put a AGC here. We can do a constant source. We can do AM demodulation. We can tell it to detect a peak. And all these these were once GNU radio blocks that we've taken and trained our AI system to use these blocks in order to generate RF signal processing chains or spectrum management plans. So you can tell SignalGPT, hey, I want to classify this signal and generate a waterfall plot, but I want to only detect peaks above X parameters. You can give it that. You can give it information on like the regulatory information, geolocation, so on and so forth. You can give it. It's an LLM. It's very open world. You can tell it whatever you want to do, and SignalGPT basically answers you. So you see here, we have so much. We've integrated so much blocks, and you can tell it, ask SignalGPT to create any signal. You can ask SignalGPT to analyze any signal. And the good thing is, you don't need to do these in a very deterministic manner. You just interact with it like ChatGPT. Exactly how ChatGPT and other LLMs have revolutionized the software development industry. What SignalGPT seeks to do is a similar concept. We seek to revolutionize the RF signal processing industry with this LLM. Thank you very much. We do hope we get this project so we can develop SignalGPT more. We can, refine it a lot more. We can improve the UI, improve the LLM natural language to SDR synthesis chain. We can add more blocks. You can see we can do EVM measurements. All these is within this AI system. The AI system has been trained, so you just tell it in a very natural language, hey, SignalGPT, I want to detect any GFSK signal across this frequency band, and SignalGPT will just whoop it up for you, and you can run your software and deploy it on real systems. Thank you so much.